Okay, class, today we're going to start with a little bit of review before we dive into im2. And what we're going to deal with today is investigating or showing how numbers can be seen as structures. We're also going to be able to find factor pairs and also talk about some divisibility rules, which I will give you in a chart format. So let's get started with structure in numbers. Okay, one of the big things in mathematics is structure, and what I mean by that is be able to see patterns in different type of math problems. So if you look at this bullet point that I have listed here, if you can determine how certain math problems are built and how you can manipulate different math problems and how each situation behaves, it makes math a little bit more simple. So I want to introduce just a simple idea of structure, just because I know this skill of recognizing structures in math is going to be very helpful, especially when you get to im3. You're going to see a lot of structure in im3, and it's going to help you understand those concepts a little bit easier. So let's shoot down to this example here of multiplication structure, and we're going to use the number 12. As you can see in multiplication, we can represent the answer 12 in a certain way. We could represent it as the number 1 times 12, just as you see here. This is the expression of 1 times 12. Okay? The visual representation, we are using squares to visually represent the multiplication of 1 times 12. If you look, we have one row, and in that row we have 12 squares or columns in that row. Okay? If you count each one of these squares, which we're going to do now, if you count them, you actually get the answer to 1 times 12. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. This pattern or this visual representation is a form of structure, recognizing that multiplication can be turned into a drawing. Okay? So that is what I mean by structure. Okay? What I'd like you to do is see if you can go ahead and represent 12, the number 12, using multiplication in two different ways below. So I'm going to pause the video. I want you to write your expression here. Give me a visual representation. Give me a new expression. Again, we're trying to equal to 12. And draw your visual representation here. So go ahead and pause the video and do that. Okay, so hopefully you got something similar to this. It doesn't have to be exact. But the first expression I put down was 3 times 4 equal to 12. And I represented it in a visual representation. We have 3 by 4. If you count all these squares, it turns into 12 total squares. The second representation I did was 6 times 2, which is equal to 12. So we have 6 squares and 2 columns here. Multiply those two together or count those and you get 12. So the next question I want you to kind of think about is, why do we call 9 a perfect square? And if you could understand this here, you're starting to see the structure in multiplication. So I'm going to draw this out for you on why 9 is called a perfect square. And we're going to use structure to do it. So 3 times 3, and the visual representation of this looks like this. 1, 2, 3, 1, 2, 3, and we fill in the rest. Count those, it's 9. And what you'll notice about this, even though it's a pretty poor drawing, this thing is making what we call in geometry a perfect square. Okay, so 9 is a perfect square because the visual representation of 3 times 3 creates a perfect square. Okay, let's move on into our next topic, which is factor pairs. The definition of factor pairs are two numbers that we multiply together to get a particular product. For example, if you look at the previous example above, 3 and 4 are factor pairs of 12 because they multiply together to give me the product 12. The word product just means the result of multiplication. So I'll write that down. So product is just a result from using multiplication. Okay, I'll shorthand it there just because we're running out of room. Okay, so when you have two factors and multiply them together, their product is the answer. All right, so we also can work backwards. If we know the answer, we could actually turn it back into a multiplication problem. And this is called factoring or finding factor pairs. So we're going to do example A, and then I'm going to have you do B and C. So I want to list all the factor pairs of A. So in other words, what I'm trying to figure out is what numbers, factor pairs are what numbers multiply to give me a number. Okay. All right, and that's what our definition is above. So let's do example A. So we're trying to list everything in pairs that multiply to 15. So the first one off the top of my head would be a factor pair of 15 times 1. Because when you multiply them together, it equals 15. The next one that I'm going to use is 5 times 3. And I think that is going to be it. So 15 has two sets of factor pairs. Okay? Go ahead and do example B and C. I will pause the video and find the factor pairs for 28 and 36. So the factor pairs for 28, you have 3, you have 28 times 1 is a factor pair, 14 times 2, and 7 times 4. For 16 also has 3, 16 times 1, 8 times 2, and 4 times 4. Okay, let's also not forget that 1 is always going to be a factor. So if you're ever struggling to find a factor pair, know that 1 will always be a factor you can use. in example D, I want you to just think about this and see if you can challenge yourself to see if you can find all the factor pairs on the number 723. It's a little bit trickier because there's going to be more factor pairs because the number is just larger. Okay? So think of this as a challenge problem. See if you can come up with all the factors. Okay guys, below is a chart of divisibility rules. And what this chart is useful for is to try to help us find factor pairs. If you're not sure of what can multiply to get a certain number, then divisibility rules can help us try to figure out what numbers can I multiply to get a number. And these are just simple rules. If you look at this chart here, and this column is, if this rule works, in this column here, then that means it is divisible by this number. So that means one of these numbers is a factor pair. Okay? So I'll let you scroll through the rules just to kind of read through them. And this is a very, very useful tool, especially if you're trying to find factor pairs. So go ahead and scroll through these, look at this, and go from there. Remember, a quick reminder, a number is divisible when you divide it and there is no remainder left over. So it divides evenly. Okay? So a number is divisible when a number can be divided evenly with no remainder. Real quick, an example is when we can take 6 and divide it by 2, we get a nice whole number, even number of 3. Okay? That means 2 can divide 6. So 6 is divisible by 2. And this helps us because it will help us find factor pairs. So now I know that my factor pairs of 6, for example, can be 2 and 3, because 2 times 3 will get me back to 6. So again, we have that same idea. Factor times a factor will equal my product. Okay? So when things are divisible, that means it divides it evenly without a remainder. And these are just some rules that will help you out to figure out what a number can be divided by and help you find factors a little more quickly. All right? Okay, so here's some explanation on these rules. In order for a number to be divisible by 2, we simply want to look at the last number. If it's even, then we can divide it by 2. So 38 is divisible by 2 because 8 is even. All right, so divisible by 2 is pretty simple. To check if it's divisible by 3, if a number is divisible by 3, you simply just add all the numbers, and if that answer is divisible by 3, then the number is divisible by 3. For example, I'm going to add 5 plus 5 plus 2. The result I get is 12. Is 12 divisible by 3? Okay, and that's the question you ask. Is 12 divisible by 3? And the answer is yes. Because 12 is divisible by 3, I now know that 552 can be divided evenly by 3. If you don't believe me, go ahead and check that in your calculator. You should get a whole number when you divide it by 3. To check if something is divisible evenly by 4, what you're going to do is take your number, in this case we have 132, and we are going to check, is 132 divisible by 4? To do this, we want to focus in on the last 2 numbers. Checking out the last 2 numbers, we have the number 32. Is 32 divisible by 4? And the answer is yes. Because the last 2 numbers are divisible by 4, we can then say that the entire 132 can be divided by 4. So 132 can now be divided by 4. To be divisible by 5, very simple. We want to look at the last number. If it ends in a 0 or 5, then it is divisible by 5. Okay? Pretty straightforward on that one. Okay, for 6, 7, and 8 divisibility rules, they get a little more complex, but they're still rules. In number 6, what you want to check is first, it has to be even, and second, it has to be divisible by 3. So you have to be able to divide the number by 3. So this one will take a little bit of work, but if you do, 84 is even, so we check that off, and 84 is also divisible by 3. Therefore, we can say it's divisible by 6. Okay. Number 7, a little more complex here. What you want to do is we're going to double the last digit. Okay. So we're going to double the last digit. So if you look, we are going to take the last digit, which is 2, and we are going to double it. So when we double 2, we get the number 4. Okay? Once you get that number, what you're going to do next is take the first 2 digits, or the other digits, and that creates a number, and the number it creates is 11. Okay? So what you have to do to figure out if this is divisible is take the digits that you have left over, which in this case is 11, and then subtract 4 from it, which we got by doubling the last digit. If the number you get when you do this math is a number that's divisible by 7, so in this case we get the number 7, and 7 is divisible, we can divide by 7, because 7 divided by 7 comes out to an even number, then we know that 112 is divisible by 7. A little complex, it's not such a good rule, but it's still one of the divisibility rules. Number 8, pretty straightforward here. We're looking at the last 3 digits. In this case, we have 032, or in other words, we have basically 32, even though it's the last 3 digits. And then we're just going to check, is 32 divisible by 8? If the answer is yes, which it is, then we now know 1,032 can be, 1,032, not 34, 1,032 can be divisible by 8. All right, and the last divisibility rule, number 9, is very similar to number 3. What you're going to do is add up all the digits. So in this case, we have 27. We're going to add up 2 and 7. And our answer is 9. So we then check our answer. Is 9 divisible by 9? And the answer is yes. Therefore, 27 is divisible by 9. Okay, those are some of the divisibility rules. Again, they will help you figure out factors if you're struggling to find factors.